All right, let's talk about how we extract stuff from the ground. So let's talk about the different methods in which we mine material. Mining can destroy, large sections of land. Oftentimes that land is not stolen, but oftentimes mining gets a bad name. There are very much some mines that probably shouldn't be where there are. Right now in Arizona, about a year ago, the state of Arizona told some company they could mine on some land, but the land really wasn't the state of Arizona. Historically, it belonged to a Native American tribe. So the state kind of did some shady business. So that's obviously a horrible example of mining and how it shouldn't be done. But mining is sometimes a necessary evil. So even when it is done in an area that's allowed for mining to be done, it can destroy the environment. It can really impact the environment and impact those that are living there. Hence, we're getting into geology and disasters and the impact of it on people. So, but mining is kind of what's called a necessary evil, because if it's not grown, it's mined. All right? There's only two places stuff comes from on Earth. It's either grown or we rip it out of the ground, right? Think about my coffee cup. It's metal. Had to come from somewhere. The plastic. Well, where does plastic? We don't grow plastic. It had to be somehow extracted from the ground. In fact, plastic is derived from oil, from petroleum. So everything, right? If it's a marker, where did the dye of this material come from? It had to come from somewhere. If it's not grown, it's mined out of the ground. So it's kind of a necessary evil. And let me show you. So every American that's alive right now, it will be responsible for, this is as of last year, 3.19 million pounds of minerals, metals, and fuels in your lifetime. So this is something interesting. So this is last year in 2020. So every American that was alive last year, that's how many millions of pounds of material they will need in order to sustain their life. Everything that they will use, come in contact with, that's how much stuff needs to be mined out of the ground. That was last year. This year, it's 2.96 million pounds because COVID has reduced the life expectancy by so much. In average, we'll need less material because COVID dropped the life expectancy by so much. So take it seriously. In fact, it's as of right now in Arizona, when this is being created, it's the #1 cause of death in the year of 2021 in Arizona. It's the only state in the whole country in which COVID is the #1 cause of death, more than cancer, more than heart-related disease. Take it seriously. In any case, so now this year, 2.96 million pounds. Everyone that's alive, that's about on average how many pounds of minerals, metals, and fuels they will need to use in their lifetime. All these different things. The biggest will be over 1.3 million pounds. So the biggest chunk of that tends to be stone, sand, gravel. A lot of stuff that we mine around here for cement, for foundations, for a number of different things. So in any case, how much gold will you need? Only about 1.5 ounces. So gold is a great conductor of electricity. You find it in higher end electronics that you may have, phones, computers, those sorts of things in small amounts. 828 pounds of copper, a lot of copper wiring, copper pipes for plumbing, coal for electricity generation, a number of different things. So if you add all that up in your lifetime, you're responsible for ripping out, on average, right around 3 million pounds of stuff from the earth, each one of us. Each one of us. How long can we do that? Right? So if each one of us, each U.S. citizen is responsible for about 3 million pounds of stuff ripped from the earth, how long can the earth sustain that? The earth is only so much. Once you take it all out, that's it. That's all you got. That's why things like recycling are so important. So if you take that out, divided by kind of that 3 million pounds over the average lifetime, on average, we're looking at about 38,000 pounds of new minerals must be provided for every person in the U.S. every year to make things we use daily. So each year, specific to minerals, we're looking at 38,000 pounds of it. So what do those include? The vast majority, again, stone. Stone is used for making roads, buildings, bridges, etc. Sand and gravel, used in concrete, asphalt, roads, blocks, bricks, cement, roads, sidewalks, bridges, etc. So the vast majority of stuff that we'll need to mine out is going to be rocks and such for oftentimes buildings, foundations for roads, sidewalks, etc. You need places to go. Right? If it wasn't for you, we wouldn't need these roads. If it wasn't for you, you wouldn't need that driveway. So yeah, kind of average all that out. That's the vast majority is kind of rocks that we're mining out. But then we get into other things like iron ore. What's iron used for? It's made usually primarily for steel. We need iron as a component of steel. Salt, not only for food, but used in various chemicals. It's used in water softeners. It's used in agriculture. In colder places, salt is sprinkled on the roads to get rid of the ice in the wintertime. Phosphate rocks used in fertilizer. Clays, we mine out clay, a type of sediment, and we use that to make floor tile, tiles for your roofs. Your plates are typically made of clay, kitty litter, bricks, etc. Aluminum for buildings, for vehicles, for aluminum cans, for cups. Typically aluminum is a lighter metal, so if this was made of steel, it'd be very heavy. Well, let's make it out of aluminum. It's lighter metal. Strong, but it dents more easily. Copper, again, electricity, plumbing. Lead in batteries. Zinc used in metal production, other things. Soda ash is something. It's the name of sodium carbonate. It's used to help make glass, medicines, food additive, a number of different things. Manganese, steel construction. Other nonmetals used in glass, chemicals, soap, paper, whatever. Other metals used in electronics, etc. So this is how much each year. And then throw in the energy fuels. So each year, on average, a U.S. citizen responsible for 843 gallons of petroleum, oil, almost 100,000 cubic feet, that's a volume of natural gas, almost 3,000 pounds of coal used to generate electricity, or 0.15 pounds of uranium. All right, so we'll talk more about these fuel sources next unit, but you can see, how little uranium we use, but it can go a long way in generating electricity. That's actually where we get the vast majority of electricity here in the Phoenix area. In any case, more on that next unit. So we use a lot of stuff, but different individuals in different countries may use less. In fact, we tend to use the highest amount of stuff. We're a very wasteful society in the United States. Other countries, even, first world countries, and other wealthy nations don't come even close to using that much material. We're a very wasteful nation. So this is just a general map looking at a distribution of different minerals around the Earth. So you can see, different places around the world have different minerals. The random kind of distribution and unequal distribution of minerals on Earth has caused social, environmental, and political consequences. It's the majority of times when we're looking, that's a third world nation, they're very poor. The reason they're poor is that they don't have stuff in the ground to mine out. The reason they don't have stuff in the ground to mine out is just blind dumb luck of where they're at. It's not their fault. It's not their fault the Earth didn't work plate tectonically in a way that would benefit them billions of years later when they existed. Not their fault. Not their fault at all. So, it's just the random unequal distribution of this stuff caused social, environmental, political consequences. Wars are started over stuff, all right? Probably the next big thing won't be any of these types of minerals. It'll be water, fresh water. My feelings on that and why we shouldn't live in Arizona. But in any case, typically poor nations aren't poor because the people there are dumb or there's no education. It's typically they're a poorer nation because they just don't have anything to mine out. They have nothing of value underground that they can sell to the world. Not their fault. Again, around Arizona, kind of hard to see, but just again, a good distribution of stuff. But one thing to point out, again, kind of middle to southern Arizona, you see a lot of mining areas, mineral mining. Really not so much up north. Remember, different plate tectonic processes formed the middle and southern parts of Arizona in the Basin and Range province. This is an area that's been extended, cracked, faulted, thinned. Magma made its way up. You know, material can make their way through these faults, so you get a lot of mineral deposits at or near the surface. Whereas up north, you didn't have that process. It's relatively flat, sedimentary process. There are some areas of coal and a couple other random mines, but for the most part, not much. So when we're talking about, so we have all this stuff, right? Mining's a necessary evil. So, okay, how do we get it out? Well, the style of mining is a function of the technology you have, social license, and economics. Social license is the ongoing approval within the local community. If, you know, next to your house, if all of a sudden they discovered gold, would you be okay with them just digging a big old pit right next to your house? All that noise, all that pollution going on? Probably not. So they might have to find a different style of mining to do it that doesn't maybe disturb you and where you live. So that's social license. So again, the style of mining is a function of, well, what kind of technology do we have? You know, if we want to do it one way, maybe that technology exists. If we want to do it in a new way, maybe that technology doesn't exist. Economics as well. What's gonna be the cheapest? Typically, if you're mining out material, you want to save as much money as possible. You know, before we kind of continue, let me give you another part of the super secret code. It is the number 0. The number 0. One more time, the number 0. So, it's typically in the best interest of the company extracting the resource to do so in a cost-effective way, the cheapest way possible. Sometimes they cut corners, and that's when issues and hazards occur. Solid resources are extracted typically in two principal methods, either surface mining or underground mining. When I say solid resources, that's the majority of what we'll talk about. When we're talking about liquid or gaseous resources, we'll save that maybe for more the mining of fuel resources, which is the next unit. So what we'll do, let's go ahead and pause here. When we come back, we'll kind of break these down, different types of surface mining and underground mining. When do we do these? When are they, when are they economically viable, etc. So we'll pause here. When we come back, we'll talk about those two. See you in just a second.